Hello everyone, I will go ahead and help you with the homework problems for our chapter 20. That's about the entropy, thermodynamics. Okay, so the first one, which of the following is true for pure oxygen gas? Oxygen gas. For the pure oxygen gas, entropy is going to be greater than 0. So the correct answer would be entropy would be greater than 0. Okay. Number 2, a certain process has delta S universe greater than 0 at 25 degrees. What does one know about the process? If the entropy of the universe increases in a reaction, that is going to be a spontaneous process. Okay, so we know if that is the case, then it is a spontaneous at 25 degrees Celsius. Okay, and number 3, which of the following decrease in the entropy of the system? Remember, if you can make particles move more, become more loosely held, so then it increases the entropy of the system. Okay, now the first one, nitrogen, we have nitrogen gas and it become nitrogen aqueous, meaning gas is going to dissolve in water. What is happening there? Is the entropy increasing or decreasing? Entropy decreases because as a gas, nitrogen particles are very far apart, so they have space between them. Once you dissolve it in water, they become close to each other, so it decreases. The first one is correct. And then the second one, hydrogen peroxide gas becoming water gas and oxygen, so that there are two molecules of hydrogen peroxide giving you 2 H2O and 1 oxygen. We have 3 molecules coming from 2 molecules. So then the entropy increases. So the B from the process, entropy increases. C, solid water, liquid water. Again, the solid, it has molecules very closely packed with each other, whereas the liquid water, they are moving. So it has a more degree of freedom of rotation. So the third one also increases the entropy. And D, oxygen gas at 300 Kelvin, giving you oxygen gas at 400. We also had learned as the temperature increases, entropy increases because the particles has more kinetic energy, so they can move more rapidly. Okay, move rapidly and can have more space between them if it is a space where you can expand the volume. Okay, so D also increasing the entropy. D, E, ammonia, liquid ammonia at negative 34.5 and ammonia gas. Again, the gas has more degree of freedom for the particle movement compared to a liquid. So the correct answer is the first one. Number 4, which of the following have the greatest molar entropy? So we have to look at whether it is a liquid, gas or a solid, and if they are gases, which one has more complexity in the molecule. So you can see here hydrogen is a gas, so this is a gas. Liquid, sodium chloride, a solid. Solid has less entropy, and then the liquid. Now we have 3 gases, and hydrogen, methane and N2O4. And out of these 3, whichever has a more complex structure would be the one that has more entropy. So which one is more complex? It's N2O4, right? So the correct answer is dinitrogen tetroxide. 5, which of the following is true for a system at equilibrium? So the first one, delta S naught greater than 0. Okay, and it doesn't have to be. And B, delta S naught system equals delta S naught surrounding when a system is at equilibrium. Well, it's the same amounts. It says C, delta S system equals delta S naught surrounding equals 0, which also we don't know. And D, delta S naught system equals negative delta S naught surrounding. So at a system of equilibrium, there is no net change. They are at equilibrium. So the correct answer would be system Entropy would be same as the surrounding entropy but in opposite amount. Okay, it would be the same but opposite sign. Equal and opposite. Delta S naught system would be equal to negative delta S naught surrounding. So the correct answer would be D. Which of the following is always true for an exothermic process? So we are looking at something that is always true for an exothermic process. Now for an exothermic process means we are losing heat from the system. So if it is losing heat, so then the heat needs to be negative. And it also asking about the delta S surrounding. If it is losing heat, so then the Q need to be less than 0. If it is an exothermic process, the lost heat would be absorbed by the surrounding. So then if the surrounding increases the heat, what happens to the entropy? Entropy of the surrounding would then increase. So the entropy would be greater than 0. So Q going to be less than 0 and delta S surrounding need to be greater than 0. So choose the one that give you these choices. Q system need to be less than 0. S surrounding has to be greater than 0. Okay. 7. Which of the following always true for an endothermic process? So for an endothermic process, the system absorb heat. So the system would increase the heat. So Q would be positive for the system. And the surrounding is losing heat, meaning surrounding become colder. So the temperature is lower now. So as the temperature lowers, what happened to the surrounding entropy? Entropy become less than 0 surrounding. Entropy surrounding would be less than 0. Q system would be greater than 0. Okay. Number 8. When a skydiver free falls through the air, the process is non-spontaneous, spontaneous, in equilibrium, non-spontaneous. Which one is the correct one? It is spontaneous, right? It just falls. It's spontaneous. Even it is free falls. So the correct answer is spontaneous. Number 9, which if any of the following is spontaneous under the specific conditions, under the specified conditions. Liquid water becoming solid water. Do you think that's a spontaneous process at 25 degrees Celsius? No, at room temperature you cannot have ice. So the first one is not correct. Carbon dioxide solid becoming carbon dioxide gas at 0 degrees Celsius. Can that be happen? Yes. Solid becoming gas, it is possible, and that is a spontaneous process. Carbon graphite becoming carbon diamond at 25 degrees and 1 atm pressure. Under room temperature conditions, carbon cannot become diamond. Okay, that's not right. And then the gaseous water becoming hydrogen and oxygen. That is also not spontaneous. So water molecule, if you have a water vapor, it doesn't separate into oxygen and hydrogen by itself. It's not a spontaneous process. So the correct answer would be B. Carbon dioxide solid becoming carbon dioxide gas. Number 10. Which relationship or statement best describe delta S naught for the following reaction? Here you have mercury sulfide, solid, oxygen gas, liquid mercury and sulfur dioxide. Okay. So what do we have here? We have solid, we can get rid of that. That's the least entropy. And then if you compare the right side, you have mercury liquid, sulfur dioxide gas. We have one molecule of oxygen this side. What do you think about the entropy? Is it the 0, less than 0, greater than 0? Entropy, do you think entropy increasing or decreasing? Entropy is increasing because a solid and a gas becoming liquid and a gas. And then also the gas, if you look at the two gases, sulfur dioxide is a more complex gas. It has a higher molar mass. Molecular complexity is also more. So the entropy would increase. Delta S naught would be positive. Okay, so the correct answer would be D. Delta S naught would be greater than 0. Number 11. Which relationship best describe delta S naught for the following reaction? Ozone gas, nitrogen monoxide gas, oxygen gas, nitrogen dioxide gas. This is balance, so 1, 1, 2, 1, 1. So 2 moles of gases giving you 2 moles of another 2 gases. And if you look at the number of atoms overall, 3, 4, 5, 2, 3, 4, 5. Both of them have 5 atoms combined, products and the reactants. They are almost similar, right? So in that case, we can say for number 11, delta S naught is almost 0. There is not much of a difference between the reactants and the products. Number 12, which of the following has the member with the greater molar entropy listed first? So both of these are solids. If both of them are solid, what you can do is you can look at their molar masses. What is the molar mass of lithium? It's about 7. And lead 300 something. So the lead is a heavy metal, so it has more entropy compared to lithium. So we are looking at the one that has the greater molar entropy listed first. And then the second one, hydrogen gas, water gas. That's not the correct. So water has more entropy. Sodium chloride solid, sodium chloride aqueous, meaning dissolved in water. Sodium chloride has more entropy compared to sodium chloride solid. D, hydrogen sulfide gas, H2S aqueous. What about that? Gas and the gas dissolved in water. So the gas has more entropy compared to the gas dissolved in water. So the correct answer is that, D. And then the last one, carbon monoxide gas, carbon dioxide gas. Carbon dioxide has one more oxygen compared to carbon monoxide. So that is also not the correct one. Carbon dioxide has more entropy compared to carbon monoxide. So the correct answer would be D. Number 13, you are given pure samples of pentane and 1,3-pentadiene. What prediction would you make concerning their standard molar entropies? So this one, CH3CH2, so if you expand this molecule to see how it's been connected, they have bonds like that. They all are single bonds like this. These are all hydrogen. So they are all single bonds, the pentane molecule. And if you take the 1,3-pentadiene, you can see there are double bonds like this. Another carbon. And then you have hydrogen. Sorry. Like this. So the last carbon has one more bond. So when you have all single bonds, so these bonds can rotate. These bonds can rotate. So it has more degree of freedom. Whereas when you have a double bond, it restricted the rotation. So because of that, the double bond has less entropy compared to the single bonded one. Meaning pentane would have a higher entropy compared to the 1,3-pentadiene. Okay. So the correct answer would be therefore B for 13. Number 14. In which of the following pairs will the first system have a higher entropy than the second? 1 mole of methane gas, 1 mole of ethane. Okay. CH4, C2H4, 1 mole. So obviously this has more entropy compared to methane, because C2H6 is a more complex. And then 1 mole of xenon gas, 1 mole of xenon at 0.5 atmosphere. So the first one has a higher pressure, 1 atm, half atmospheric pressure. So in this one also, the second one, when you have a less pressure, meaning it has more entropy. So the second one would be higher entropy. We are looking at the first system. C, 1 mole helium, 1 mole krypton. Helium molar mass is 4, krypton molar mass is higher than that. Okay, so the krypton has more entropy. 1 mole O2, 2 moles oxygen atoms. Of course, when the atoms are, there are 2 moles oxygen, whereas here has 1 to 2. So the second one has more entropy compared to the first one. And then $21 bills distributed randomly among 20 people. And then $21 bills distributed randomly among 10 people. It's like first one you have 10, 20, and then the second one has 10. So which one has higher entropy? So the first set has higher entropy, where $21 bills distributed randomly among 20 people would have a higher entropy. Okay, so the correct one is E. 15, in which one of these pairs will the entropy of the first substance be greater than that of the second? These questions, you guys can also do these ones, right? 1 mole of iodine solid, 1 mole of iodine gas. Gas has more entropy compared to solid, so that's not correct. 1 mole of fluorine, 1 mole of chlorine. Fluorine molar mass, I think it's 19 something, whereas chlorine 35.45. So chlorine has higher entropy. 1 mole O3, 1 mole O2. Which one has higher entropy? 1 mole ozone or 1 mole oxygen? That's going to be 1 mole oxygen, right? So the C is correct. And then 1 mole calcium carbonate solid, 1 mole calcium oxide solid, plus 1 mole carbon dioxide gas. So the second one has more entropy. 1 mole hydrogen, 1 mole hydrogen at 50, 25 degrees, 50. So the second one has high entropy. So out of the 5 choices, 1 mole ozone has high entropy than the 1 mole oxygen. Which of the following phase changes decrease the entropy of the system? Heating a gas would increase the entropy. Melting also increase. Vaporization also increase. Condensation, the liquid, what happened in the condensation? The gas particles become liquid. It decreases the degree of motion of the water vapor. So condensation decreases the entropy of the system. Sublimation also. Sublimation means solid become gas. That also increase entropy. Number 17. Calculate delta S naught for the reaction. How do you calculate delta S naught? So you use this equation, delta S naught equals sum of all the delta S naught values for the products minus the sum of all the delta S naught values for the reactants. And you also need to take into consideration the number of moles. So this is 1, 1. So these are going to be your product. So your products are going to be MgCl2. You take this one. 2 times 89.62 plus silicon 1 mole 18.83. That's your products. Add it up and you subtract your reactants. SiCl for 1 mole 330.73 plus magnesium. There are 2 magnesium. 2 times 32.68. Products entropy minus the reactant entropy, and then you can find the correct answer. Okay, you can find the answer and do your own calculations. And number 18, for a chemical reaction to be spontaneous only at higher temperature, which of the following condition must be met? It's not asking spontaneous at all temperatures. It's just spontaneous only at high temperature. So what does it need to be done? So remember, delta G equals delta H minus T delta S. So delta G need to be less than 0 or negative in order for a reaction to be spontaneous. Okay, at high temperature, if the temperature is high, right? So we want to make sure this part need to be higher negative. It can be delta H could be positive. Okay, because this is asking only about higher temperature. If the temperature is high, to make this part highly negative, what does delta S need to be? Delta S need to be positive, because this positive times negative sign will make the negative part of the equation higher. So the delta H okay to be positive, but the delta S also needed to be greater than 0. Okay, so on these two conditions, delta S needed to be greater than 0, delta H needed to be greater than 0. So you choose the correct answer from this set. Number 19, excuse me, in order for a process to be spontaneous, delta H must be less than 0, doesn't have to be. Delta S must be greater than 0, doesn't have to be either. Should be rapid, delta G must be greater than 0. No, delta G need to be less than 0. Delta S system and this delta S surrounding must be greater than 0. Exactly. Delta system and the surrounding should be greater than 0. So then the universe will feel it and it would be a spontaneous process. Okay, so the correct answer would be E. Number 20, given liquid water going to gaseous water. Delta H naught is given as 40.7. What is the entropy change in the system when 1 mole of water vaporizes at 100 degrees Celsius and a pressure of 1 atmosphere? So water need to vaporize, going from liquid water to gaseous water. And in order for that to happen, delta G must be 0. So delta G, we use this equation. Delta G equals delta H minus T delta S. Okay. So when this happens, when the liquid water becoming gaseous water, delta G will become 0. We can make delta G 0. So we are trying to find out entropy change in the system. Delta H therefore would be T delta S would be 0. So then the temperature, we are wanting to find out entropy change delta S. Delta S would be then delta H over temperature. Delta H was given 40.7, and then you're going to divide it by the temperature, 373 Kelvin. Because the delta H 373 is 100 degrees Celsius, right? 100 degrees Celsius, when you are 273, that would be 373. So you divide it by 373. Kelvin. 40.7 divided by 373. And that was kilojoule. And here it is asking joules. So since this is kilojoule, you can convert it to joule by multiplying 10 to the power 3. Did you get it? Okay, 40.7 convert to joules because it's kilojoule. So you multiply by 10 to the power 3 to make it joule. 1 kilojoule is 10 to the power 3 joules, and you divide it by temperature 373. Number 21. The second law of thermodynamics tells us that the universe proceeds towards a state of lower entropy. No, it goes to a higher entropy. It's the E. The universe proceeds towards a state of higher entropy. Okay. 21 would be E. Calculate delta G naught for the reaction. How do you calculate delta G naught? Again, we use this equation, delta G naught. Since the delta G values are given for individual compounds, sum of all the delta G naught values for the products minus the sum of all the delta G naught values for the reactants will give you delta G naught for the reaction. And our products are going to be magnesium chloride and silicon. These two. Also take into consideration number of moles. So 2 moles magnesium chloride, 2 times negative 591.79 plus silicon 1 mole times 0. Subtract your reactants, SiCl4 negative 616.98 times 1, because it's one molecule and there are 2 magnesium, 2 times 0. So solve this problem and you can do a calculation, so you can find out the delta G naught for the reaction. Number 23. Use the given data at 298 Kelvin to calculate delta G naught for the reaction. Okay. Now for this one, we are given delta H naught and S naught. From these values, you have to calculate the delta G naught. For this one, we're going to use this equation, delta G naught equals delta H naught minus T delta S naught. Delta H naught, how do you find out? So these values for delta H naught given are for individual complex molecules. So you have to find out the delta H naught for the reaction. How do you find the delta H naught for the reaction? Just like we calculate delta G, you have to calculate delta H. Calculate the delta H naught for the reaction using the sum of all the delta H naught values for the products minus the sum of delta H naught values for the reactants. So this is reaction, these are reactants. Right, so your products are going to be SOCl2, Cl2O. And your reactants are these two. So you do this calculation yourself. You can do that. And then also you have to do delta S naught for the reaction. There would be sum of all the delta S naught values for the products minus sum of all the delta S naught values for the reactants. And for the S naughts, this is a product, this is a product. And these two are reactants. And when you are calculating, make sure you take into consideration the number of moles. So basically chlorine needs to be 2 times. Okay. And you find delta H naught separately, delta S naught separately with the given data, and you use this equation, delta G naught equals delta H naught reaction that you're going to find from your calculation, negative T delta S naught reaction. And then the temperature 298. So the temperature you're going to put 298. Okay. Delta H naught values are given in kilojoules. Do you see here? It's kilojoule. When you calculate, your delta S will come in joules per Kelvin. So once you get your delta S naught in joules per Kelvin, you have to convert it to kilojoules because your answer is given in kilojoule. Okay, the value that you're going to get from here, delta S naught, make sure you convert this into kilojoules. Answer. You will get the answer in joules converted to kilojoules. And then you can perform this calculation. Otherwise, your answer will not be correct. Okay. That's how you would find the delta G naught. For question number 23. And number 24. A diamond is forever is one of the most successful advertising slogans of all time. But is it true? You're going to find it out. For the reaction shown below, calculate the standard free energy change at 298 Kelvin and determine whether or not a diamond is forever. Now let's see. We're going to find out the delta G, and we are going to use the equation delta G equals delta H minus T delta S. Okay, we're going to be using this equation delta G equals delta H minus T delta S for the reaction. And we are given delta H for the diamond. And then since a carbon, delta H would be 0. It's not given here, but just know that delta H naught formation for the carbon is 0. So delta H for this reaction here, we're going to find out the delta H naught for that reaction. Product is graphite, carbon, delta H is 0 minus diamond, delta H formation diamond 1.895. Okay, so 0 minus 1.895, so the delta H naught would be negative 1.895. And then you have to calculate the delta S naught. Again, the product minus the reactant. Product is graphite 5.740 minus 2.337. Again, note that it will be given in joules. This would be 3.403 joules moles per Kelvin, and you need to convert it to kilojoules because the answers are given in kilojoule. And then the delta H 1.895 also here, kilojoules per mole. Now you found delta H naught negative 1.895 and delta S naught 3. This value in joule. So make sure to convert it into kilojoules. 10 to the negative 3 when you convert it to kilojoules. Okay, and then you put it into this equation. You put delta H as negative 1.895 and then the temperature is going to be 298 Kelvin. Use the temperature as 298, and your delta S would be 3.403 into 10 to the negative 3, okay, as delta S, and you can find out your delta G, whether the diamond is forever or not, okay. And number 25, hydrogen sulfide decompose according to the following reaction. For this reaction, 298 Kelvin, delta S naught, delta H naught, and delta G naught given. What is the value of delta G naught at 900 Kelvin? So for this one, again, we're going to use delta G equals delta H minus T delta S. I'm going to find out delta G naught 900 Kelvin, and delta H naught is given as 169.4 kilojoule, and then the temperature 900, we're going to find out at 900 degrees times delta S naught 78.1 into 10 to the negative 3, making it to kilojoule, okay. 900 times 78.1 into 10 to the negative 3, converting it to kilojoules. So this will give you delta G naught at 900 Kelvin, okay. And number 26. The temperature at which the following process reaches equilibrium at 1 atm is the normal boiling point of hydrogen peroxide. Use the following thermodynamic information to determine this temperature. So we're going to find out when the liquid water becomes gaseous water, okay. Again, we're going to use the equation delta G equals delta H minus T delta S. So there is a phase change happening. So when the phase change is happening, delta G is going to be 0 when it reaches equilibrium, okay. So delta G would be 0, so then the delta H equals T delta S, and the temperature would be delta H over delta S. How do you find the delta H? You are given delta H values for the liquid water and gaseous water. So you find the delta H for the reaction, product minus reactant. Your product is H2O2, negative 136.3. So you find delta H. Your product, negative 136.3 minus negative 187.7. That will give you delta H naught for the reaction. And similarly, you find out delta S naught. That would be 232.7 minus 109.6. You get that answer. And that's in joules. This is in kilojoule. So this the answer need to be multiplied by 10 to the negative 3 to make it kilojoule. Once you get the two answers, you plug in here, delta H and delta S, and you can find out the answer. And once you get the answer, it will be in Kelvin. So you subtract 273 to find out the answer in Celsius, since the answers are given in Celsius. Number 27. Calculate the equilibrium constant for this reaction. and you are given delta H naught values, delta G naught values, and S naught values for the individual compounds. So again, you have to calculate delta H naught and delta S naught and then the delta G naught to proceed for this reaction also. So we are going to use this equation, delta G naught equals minus RT ln K. We know the gas constant. We also know the temperature, 25 degrees Celsius. And we want to find out the K. We need to find delta G naught first. How do we find the delta G naught? These, okay, you can use maybe you can try both this and see. What do you do? You can find out the delta G naught with this equation, delta H minus T delta S. Okay, and then how do you find the delta H naught reaction? You can find it out using the same equation, sum of all the delta H values for the products minus the sum of all the delta H naught values for the reactants. And then we have your products, carbon dioxide and hydrogen, and these are your reactants. Take into consideration number of moles, 2 water molecules. And find the delta H naught. Similarly, find delta S naught. Sum of all the delta S naught values for the products minus the sum of all the delta S naught values for the reactants. That will give you the delta S naught value. Once you get that, you can calculate the delta G naught. When you calculate the delta G naught, once you get that number, you can use that with the equation delta G naught equals minus RT ln K. So then the ln K would be delta G naught over RT. And then the temperature is 25 degrees Celsius. So you add 273. Temperature would be 298. And then the gas constant is going to be 8.314. Joules per moles per Kelvin. And then you find that answer here, and then once you get that answer, you can find out K would be E, the answer you get from there. That will give you equilibrium constant. That's 28. And number 29, what is the free energy delta G naught for the equilibrium between hydrogen and iodine when Kc is given 0.02. So we are given Kc. Did we do 28 or is? I think we skipped 28. The reaction of methane with water to form carbon dioxide and hydrogen, non-spontaneous. At what temperature will this system make the transition from non-spontaneous to spontaneous? it happens when the delta G become 0. So we are going to use this equation again, delta G equals delta H minus T delta S. This would be 0. So the temperature going to be delta H over delta S. You have to find out the delta H reaction. You have to find out the delta S for the reaction from these values. Find out using this kind of equation, and then you can plug the numbers to this equation. T equals delta H over delta S. Number 29. What is the free energy change delta G naught for the equilibrium between hydrogen and iodine? So for this one we are going to use this equation, delta G naught equals minus RT ln Kc, since the Kc is given. So we are also we're trying to find out the delta G naught. So negative are going to be 8.314, and then the temperature 453 degrees Celsius. Make sure you add 273. Hello. මම රෙකෝඩින් එක නෑ නෑ. ඔව්. I'm sorry about that. Plus 273, so make sure you convert it to Kelvin. 8.314 times 453 plus 273, and that is going to be your temperature, and then the ln Kc, and then the Kc would be 0.02. That will give you delta G naught. Okay, so that's 29. And 30. 30, a reaction has delta G 10 and delta G naught 15. Calculate the value of the reaction quotient under these conditions. So for 30, we're going to be using this one here. We use delta G equals delta G naught plus RT ln Q. Since it's asking, calculate the reaction quotient. Delta G is 10, delta G naught is 15, R 8.314, and the temperature 50. 273 plus 50 would be 323 ln Q. ln Q. So 10 minus 15 would be negative 5 from this side, and you divide it by 8.314 times 323. So this is joules per moles per Kelvin. Joules. Okay. So you want to make sure this value you're going to get from here. need to convert to kilojoules. So when you convert it to kilojoules, you will get a number like this, 2.68. Maybe you guys can do, yeah, 2.68. There would be ln Q, and then Q would be e to that value. Maybe it's a negative value. That will give you reaction quotient. Okay. All right, then that's about it. I'll talk to you later. Bye bye.